Good afternoon, everyone. Today, I will give you a short talk about multi-class classification of CFFAR 10. This is my outline. In the beginning, I will share about the data set that we apply it, and the model, and evaluate, and I did some hyperparameter, and evaluate our model. Our data set is CFFAR 10. Is a 60,000 colorful image. The size is 32 by 32. Is a is a 10 mutual exclusive classes, and I only use 10,000 training image to predict another 10,000 training images. And I use the pre-trained model ResNet 50 and only trained the customer classification head. And I do some hyperparameter. And the first one is to increase the dropout numbers and tune the L2 regularization there. And finally, I try to unfreeze the that has 100 layers and to see the performance of the modeling. Before building the model, I pre-processing the data, and I can see that the image is blue, so I try to apply the Gaussian blue, medium blue, and the sharpening filter. Finally, I decide to use the sharpening filter. It's 3 by 3 corners, and to improve the contrast of our image. And this is our modeling. The best model is the netness of 50, and I enforced the best model, and only trained the head model, the head part. And I try apply to the L2 regularization and the batch normalization, and applied three neural layers, 256, 128, and 64, and use the sulfur marks as the activation function. And based on this visualization, the loss and accuracy between training and validation, we can see the model is overfitting and fluctuation. So we try to twice dropout. The first dropout is after the first dancing layered, and the second dropout is before the output. And we based on the visualization, we can see that it improves a lot about the overfitting, and it also improved the fluctuation. And we increase the L2 regularization weight from 0.002 increase to 0.005. And we can see it improve the fluctuation. But for the accuracy, it only improved a little bit. And then we try to improve the accuracy. So we unfreezing the last 100 layers and combine with slow down the learning rate from 0.001 to 1 powers minus 5. And we can see the accuracy increase from 60% to 70%. So it increased about 10%. Yeah. And based on our best model, the accuracy is about 78%. If we did not, consider the sample size, so the average F1 macro, the average F1 score is 0.71, and the weighted average F1 scored is 0.71. So the data does not exist severe imbalance. and based on our modeling, the good performance is class 1, 8, and 9. These classes belong to the traffic vehicles, and the poor performance is 3, 4, 5. And these three classes belong to the animals. So based on our modeling, the traffic vehicle prediction is better than the animals. This is my first time to do the NestNet 50, and in the beginning I didn't have confidence to finish this project, but after doing and tuning the parameter, I know which parameter affects the result, and I gained sense of achievement by working on this project. So I enjoy this coding process. Yeah, this is my final slide. Thank you for your attention.